Okay, a very good afternoon to all on frequency. A good morning to you, Ed. Just want to turn this audio down a bit. I had a problem with the stream. It said a poor stream. So I had to quickly redo it, but it seems okay now. Yeah, very good afternoon, good evening, and of course, good morning to you there, Ed. Welcome aboard. Today we have another interesting program, thanks to Leon and hopefully Mike and the stalwarts. We also just want to take the opportunity of thanking AMSAT DL, AMSAT UK, and of course the BATC, and then very importantly the Qatar satellite company for allowing us the opportunity to use part of their satellite. Let's just see who's on the list today. Just want to quickly go and hook that up. There we go. Oopsie. Sorry, guys. Let's see. There we go. Okay, on the list today, Mike's dropped off. It's ZS1 Mike to follow, and then hello, Matt, Mike 0 Delta Quebec Whiskey. Hello to Martin, G8KOE, and then it's Mike, Golf 0 Mike Juliet Whiskey, and then Ed, Papa Yankee 2 Radio November. Hi there, Ed. I see somebody's playing around with the thing, but we'll see who else wants to come up in a minute or two. Let me just take these things off, and I'm sure there's somebody WhatsApping me as well. Right, as I mentioned, I have a little very quick program. I haven't been too busy with amateur radio things of late. I've been just far too busy at the salt mine. But I got a Grundig satellite 3400 professional, they call it. Beautiful receiver. It was cosmetically in very good condition, but not working well. So there's a chap called Manuel. He's on YouTube, and he put through a whole series of fantastic videos on the satellite, how to line it up, tune it up, and he kindly sent me the instruction manual, or the technical service manual, which helped a lot. So that is what I was busy with this week, and it was quite strange to see me busy with amateur radio stuff, to be honest. I just don't really have the time, but let's take you through this quickly. It's not a long thing. That's the unit already stripped, so you can see it's built like a tank. Beautifully done, mechanically very strong. And so that's the front panel off. And that's where you do your alignment, actually, on the shortwave bands in any event. And some of the toggle switches were a bit dirty and had to be fixed. This particular photo, I've already removed the power supply stroke audio unit. Biasings weren't correct. There it is. It's out of its shell with 100 wires to solder on afterwards, but it all recapped everything. So all done. And then, of course, the FM unit also needed a bit of a recap. Chucked out the tantalums. I think there's only one on that board. That's what it looks like all put together again. Quite nice. And then I had my station engineer test it. Actually had a bit of a giggle at him. He's 8 years old now. And I said, oh, I wish I had a nice antenna that we could listen to what shortwave's about. And he said, Grandpa, but you've got the beacon next door. Let me just see now what's going on. He says, you've got the beacon next door. Why don't you tune onto that? I thought that was really out of the box thinking. I run the ZS6DN beacon. So I grabbed him by the ears and gave him a little kiss on his forehead. I said, now you're thinking like a real radio amateur. Anyway, it was all good fun. Leon, I want to thank Leon profusely. ZS1 Mike. He gifted me something fantastic. It arrived as a surprise in the post, well, in our courier at my house. And it's nothing less than the Marconi Sanders thermal watt meter, type 6460. It is super accurate, but Leon can tell you more. He used to work with these. But this is something really. I've got it on right now and it hasn't budged. I'm on 16 watts at the moment, running just over 5 amps. And it hasn't budged. It's what the hell am I doing now? Let me just get this. Sorry. Yeah, let me just see. Signal strength is good. So I'm quite happy with the result, and it's very nice to be able to just glance at what output power you're doing. And of course now you can work out the efficiencies very well. But it's a fantastically built, it's brand new. I tell you, Leon's got two, I think, but one he gifted to me. So now we're playing with it. It's the first time I could play with it today. I had to get the Grundig basically off the table. But now, having said that, let's bring in Leon, ZS1 Mike. Would you please take it, Leon? ZS6YI. Would you please take it, Leon?
Okay, thanks Gary. ZS6YI in the group. ZS1 Mike saying good afternoon, good morning to Ed, and yeah, good evening to the guys in India if they're still there or still watching or listening, maybe just in receive mode, and in Israel. Okay, yes, just before we start, Gary, as I told you, this is the book for the power head of that Marconi thing. I'm pretty sure I have got the machine's manual somewhere, because I remember now reading up something inside there. So I must have it somewhere between the two houses. So when I get to Bredasdorp again, I'll have a look there as well. I think it's also a blue book, but it's much bigger than this. Yeah, and then the capacitor in the spectrum analyzer that gave me so much trouble was this one. I'm going to hold it against the book so that the camera can maybe focus on it. It's very tiny. It's a tubular ceramic condenser. There it is, little blue one with colored dots on the top. And it's gone leaky, 1.8K. I mean, who would ever expect a thing like that to go leaky? It took me 2.5 days to find that problem in the IF, in the narrowband IF filter of the spectrum analyzer. Anyway, replaced it, and it's working fine on all the resolution bandwidths. Now it goes right down to 10 hertz resolution bandwidth. So that's very, very, very narrow. Okay, last week we watched this one, the launch of the Phoenix 1D rocket at my salt mine. So, as I told you, there were two onboard cameras on that thing. That was my involvement with it, was to make sure that it interfaces correctly with our telemetry equipment at the telemetry station where we will receive the stuff. Anyway, so it had two cameras, one looking straight down and one looking sideways. So the sideways camera is too much spinning there, but the camera looking down is that one. So that's just before launch. It's looking at the ground, at the launch pad, and some of the launch ramp structures and so on. We recorded it on a DVD recorder at the telemetry station. But, even that digital thing couldn't keep up with all the motion in the picture. There was so much motion because the rocket spins. But anyway, you'll see there's the time. That was the actual time. It's 1651 minutes and 60 seconds. There it goes. And you can see it's rotating. And there it's going through the clouds. And then it's just looking at the clouds. You just see that the clouds just get smaller and smaller and smaller, because that thing really travels. it is.
Is going.
Yeah, okay.
Your lungs.
It's just my receiver that shows us history. And now it went into a flat spin. And because it was in a flat spin, it braked so much, the air resistance is so much, that it took about 7 minutes, just under 7 minutes to be back on the ground. So nobody expected the thing to go in a flat spin, because the bottom end of the rocket is much heavier than the nose part. So one would think that it would either fall back in reverse gear or, due to the airflow, go down nose first. But it didn't. It went into a flat spin. And it's really going crazy. So I don't think I should bore you with 7 minutes of flickering video. You can see the picture is already getting pixelated and blocky. And that is due to the DVD recorder. They just couldn't keep up with all the motion. So yeah, that's the downwards looking camera on the Phoenix 1D rocket. I also have video that I took of the 1C rocket, which was fired a few days later after this one. That didn't have cameras on it, it had all sorts of other instrumentation on. But I do have footage of the launch and the preparation and so on. I'll show that at some later stage. And now we're only 2 minutes into the descent, and it's still got another about 3 or 4 minutes to go. So I think I'll just stop it there and put it back to this monkey here. Okay, that's about it from my side for today. Matt, I see it's you next on. So I give it to you. Mike 0 Delta Quebec Whiskey for the group from ZS1 Mike. Where's the power?
Testing audio 1 2 Sam 0 DQW. Okay, that's working. Thanks, Leon and Gary. Thanks very much. All very interesting. I wonder if you could elaborate more information on the power meter that you've got, Gary. One of the things I'm going to mention about or talk about today is my ongoing project of managing or creating a meter of some kind so I can monitor the power output from my amplifier. I've tried so many different things so far, but one of the problems that I have here is one of the problems I have is I don't actually have any calibrated equipment to compare the readings, but I know when something isn't working right. So anyway. My last attempt at measuring the power output from the amplifier was using a coupler and then using one of these. I don't know if you've seen these sort of cheap Chinese RF power meters, but when I had that configured and in line, it said I was putting the amp was putting out like 300 watts. Well, obviously that was completely load of tosh, so I don't know. So my next adventure into measuring power from the amplifier is going to be, now I'll tell you, Martin G8KOE, he gave me the idea of researching this, and let me just do this. So I was looking for a method of how you do it via a diode, and I came across this website, and hopefully you can see all of that. And who the DL5NEG come up with this has got this sort of design here. So I've ordered all the parts and got the board, so I'm going to be building that and he's also got a chart as well, which shows sort of how much voltage that'll be coming out, that will come out of it, depending on what the input power is. The whole idea will be to feed it into either an Arduino, which will then go into a Raspberry Pi Node Red, or it'll just go straight into like an ADS 1115 analog to digital converter, and then I can show it on my Node Red display. But yeah, unfortunately, the whole idea of using this, I thought it was going to work, and it did work. And it worked extremely well. I had it connected to another Raspberry Pi running Node Red, and that was sending MQTT packets to the broker running on my Pluto, which I was then picking up from the Pi in my QO-100 transceiver. So anyway, it worked in the sense of I got the data, but it just didn't give me the right readings. So anyway, so there we go. I think I really need to invest in a calibrated power meter for 2.4 gigahertz. That's what I need to do. I need to do that. Then anything else that I build, I can make sure that it is working. Chris, a makeup department. I just caught that on the screen. Yeah, I do my own makeup. What else have I been up to? I don't know if you guys have ever used these makeup for what? Yeah, my face, obviously. That's quite easily resolved, actually. I can just use a bag, just a brown paper bag. You guys are the only people that see me on camera. I'm even on my YouTube channel. I literally rarely go on camera, so. Yeah, you're lucky you haven't just got a picture of something in my voice. But anyway, back to the topic. In my RF testing with stuff, I managed to break 2 dummy loads. These cheap dummy loads, that I'll say they're cheap, but what I didn't realise was that this particular one, it's DC to 1 gigs, and I've been putting 30 watts or anything between 1 and 10 watts of 2.4 gigs into it, and anyway, it's broken. So I've done some research, and I'm going to build my own. In fact, I'm halfway through recording a video at the moment, and just literally going to be building one with a single resistor, and then obviously heatsink, etc. So that's going to be on a video soon. Might even be my next one, and they're just using some resistors that I got for Amazon, actually. Trashing the place, and just a little strip of resistors. They're 100 watts, 50 ohm. Obviously, I only can use one of them because I want to keep it for 50 ohm for the 50 ohm match. They can be junk mat. Yeah, I think you're right. I think there's a rally coming up, isn't there? I quite like it, actually. The Dunstable, it's like a car boot. Dunstable Downs Rally. It's like a car boot, so I think I'll probably go there, actually. So that's what else I've been up to. I've been experimenting with a couple of devices, receivers that people have sent me, that companies have sent me. Not particularly new. I'll be doing some videos on these soon. This one here is a Reticus TR110. This actually works quite well. It does all mode, which is quite surprising, and it does all the way up to UHF as well. So you can get HF and air CB, VHF and UHF. So it's very, very light, and it's got a little telescopic antenna on it. So I'll be doing a video on that soon. And also, this is what I'm really impressed with. I didn't realise he's been out for a while, but the guys, they sent me one of these. If I can turn it on, you might be able to see the screen. get it to focus. There we go. And these have a little inbuilt, they have a speaker in the back, and it's absolutely brilliant. It works so well. It's really good, and it's got internal battery as well. So, but that's just 0.1 to 31 megs all mode. But these are, I don't think they're particularly cheap. But yeah, it's going to be interesting to try that out. Just on my notes, yeah, thanks for showing the footage, Leon. Absolutely awesome. And I'm just wondering, will you be uploading that? Will you be uploading the video to like YouTube or something, just so that we can see the full quality? I think that would be really good. Obviously, quality coming through here, we can see it. Well, for me, I can see it, but it'd be interesting to see what it looks like on full resolution. And as you can probably tell, I've changed my camera. So I'm now using, instead of the cheap webcam that I had, I've invested in a Canon EOS M50 Mark II, if anybody's interested, and that's connected via a Camlink 4K USB adapter capture card. And I've also invested in some lighting, which I've been playing around with, trying to make things look good. Okay, it's enough waffle from me, so we'll put it over to who is up next. Martin, G8KOE, and I haven't even unboxed the dish yet, Martin. So I got a dish off Martin, a 1.8 meter dish, and I haven't even unboxed it yet. It's we've had lots of work going on here, so like roof fixing and stuff like that. So I just haven't really had a chance to do anything. Anyway, so over to G8KOE from M0 DQW.
Yes, thanks there, Matt. Let's make sure it's sound before muting it. Yes, thanks there. That's easy. Do like the open tuner with a nice big mute button there. Makes it a lot easier. Yeah, I'll talk about dummy loads and such like. I'll drag in what I use. And the one you're constructing, I saw you using a 259, weren't you? I didn't think anybody used those anymore. But anyway, I shouldn't criticise, should I? It's either N-type or SMA, I would have thought. But yeah, I think they're horrible connectors. What have I been up to? Oh yeah, fun on the rocket pictures, etc. Absolutely amazing, and I'm still feeling seasick. But yeah, it's interesting, very interesting indeed. So thanks a lot for those there, Leon, and cheer there, Gary, on that constructional project or dismantling and put right. You're right. Yes, you should get all the SM259s and sort of throw them away. I should stop being rude, shouldn't I? No, that's what train of thought. But yeah, thanks there, Leon, for the pictures, etc. And Gary there, yeah, your construction or your repair job. I don't think I'd take that on anymore. But anyway, yeah, as you probably know, it's going to go on and on and on, isn't it, this 259? As you probably may or may not know, didn't nearly make last week's net because I was having all sorts of problems with the Pluto dropping out. The USB side would sort of lose and it'd keep opening up more and more windows. And I tried all sorts of things. I reloaded the firmware on the Pluto and the drivers on the PC, and put a little hubbing line so it was powered, etc. Not off the PC, except and when ever decreasing circles. And then I suddenly looked at what the Pluto was, because my first Pluto died, and my attempts to repair it didn't succeed. So that was a replacement one, and it's a B. And I suddenly woke up to the fact that it was the same as the first one I had, and the early ones used to suffer with the USB dropping out, which there was a little Earth mod. Let's see which picture is it. Not that one. I'll come back to that one in a minute. Which is that little link, which I hadn't done. It's I think well documented everywhere. I just assumed that I'd done it, because I'd done it on my first one. So I popped that in, and stability seems to be now back. Just if anybody else has forgotten that's what they did when they first got a Pluto and it was causing problems. Yeah, so worth remembering. Let's go back to the previous picture. Well, there's my pick-off point, as you can see. We're looking at the power. It says I'm running sort of 38 watts at the moment. I haven't really. It says 40 watts. It sort of flickers around a little bit, but there's that little piece of Vero board at the top there, which has a diode and a capacitor on it, and I think I've got a resistor as well, and it feeds all the way down into here and straight into my Uno, Arduino, straight into the analog input. And that's it. And I use the DATV Easy piece of, and that's just monitoring that. It measures the volts, it measures the current now, and it measures the power. And that's all I've done to measure the power. So it's nothing complicated. In-mail to SMA adapter, I think. Why would I want to get that? You're looking at the adapters at the top there. Now I have a problem that there's a mismatch. That's not what I've got in there at the moment. But every time I try and put the right sort of connecting arrangement up the top there, I lose power. I think that's probably what you're referring to. So at the moment I've got a very small length of cable up there, which works well. Let's go back to the camera. It's probably frightening for everybody. And I was going to show the outside world with sunshine, but we don't seem to have any sunshine anymore. It seems to have gone away. Anyway, I'm sort of waffling a lot here. Don't think as I said, I'll get some what dummy loads I use and drag in so that I can show and annoy people. Anyway, Mike's going to come up with obviously lots of correct bits of information. I don't have any sensible way of measuring the power, although I do have a PA that's supposed to give X amount of power out, which I can use as a calibration, sort of commercially built one, which I shall probably use that to give me a rough point. Though I was, when I was playing with the PA recently, though you're not supposed to put your finger anywhere near, I'd forgotten what an RF burn was like, and that hurt. I think I'm probably running about 40 watts out of the PA. And I was keeping well away from it, as I was sort of trying to improve things. But there we go. Right, it's down to Mike, who I was struggling to copy you. When you didn't have a transport stream, I thought things had played up here. I did hear you this morning on at the narrowband end. I sort of had hoped to be operational on there by now, but things didn't go according to plan. I'm having to have a rethink slightly, and I'm going to do things slightly different. The PA didn't like going down to low enough power. It got very upset. So, but anyway, I was using my SDR Play, testing that and listening to you. I'm finding SDR Console, whether anybody else, so it seems a bit sort of resource hungry, and the refresh rate of the screen seems to be a lot jerky. Maybe there's some settings you can change to make it less resource hungry in that way, but we'll see. Right, that's certainly enough waffle, but it was a good signal from you there, Mike, and Graham also. I'd like to say hello to him. I haven't spoken to him for, I don't know, probably tens of years. I don't know how many years, but they are too. Used to spend a lot of time chatting with regards to repeaters in the early days. Anyway, test card and over to you then, Mike, from Golf 8 Kilo Oscar Echo.
Good. Right, thank you, Martin. A few things then to comment on. Just checking everything looks like it's working. Can't see any issues, so hopefully it is. Firstly, Gary, that grounding satellite receiver, that's the sort of thing we really all wanted in the 70s, late 70s. Lived in Italy at the time, had the Sony, but that was the ultimate receiver to have. So glad you got it working again. And Leon, this rocket was very interesting. I just think about the flat spin, and I was also listening to the rocket audio. I assume it was the rocket audio. It might have been the audio on the site. But when it gets very high up, there's very little air, so there wouldn't be very much air resistance. So as it got into a spin, it got into a flat spin. It would then stay in that flat spin, and as it got lower down, presumably then the gyroscope effect would mean that it wouldn't be able to get into any other sort of attitude. So that might be what was happening there. It's the sort of thing that happens to aeroplanes, isn't it? They can get into a flat spin and they can't get out of it. It's one of those aerodynamic curiosities. Anyway, Matt, the power meter, right. I didn't have anything to say, so I got a few things out as you were talking. Those power modules from China, they do work, but I never got them to be very accurate. They seem to change, and obviously the match is important. You can improve that by putting an attenuator in front of it, assuming you've got enough power. Anyway, firstly, this is my milliwatt meter, well, one of my milliwatt meters that I got from Justin, and it's his own board with a pick, and then I added an Arduino. Oops, you can't see the Arduino. There you go. That's an Arduino Uno in there, so that I can, get information out of it. I think it is one of those analog modules. It goes up to 10 gigs or thereabouts, and it does seem to work, but it has to be calibrated for each frequency band. And I did a calibration as well, and Justin did one too. Example of good N-type dummy load, which you can pick up at a rally, potentially, if you know what you're looking for. That's a 50 watt one, but I wouldn't use it at 50 watts for very long. But what you really want to get, if you can, is one of these. Now, you've got to get there before the dealers, which means turning up to the rally early. Now you notice it's got an input and an output side to it. This is a 40 dB attenuator, 250 watts, and it's ideal for testing that sort of thing. It's pretty heavy, pretty hefty. Make sure you don't put the power into the output side because it can only handle 50 watts. And this is not a resistor. Well, I suppose it's 3 resistors. This is an attenuator. Is it going to focus? It's not looking at me. No. Well, maybe. Same sort of thing anyway as those resistors that you had. This is the 10 dB one. Again, it's directional as well, although they don't tell you that in the listing, but it does have a side input and output. And they're very good. I put one in the front end of my HF amplifier I'm building to avoid overdriving it. I've also ordered another one, a 6 dB one, because if I want to run it from the IC705, it hasn't quite got enough drive to overcome a 10 dB. And finally, this is the Balka DX. I've had this for a few years now. It's the predecessor to the one you've got, and it has got a speaker in it as well. This one only goes down to 1.5 megahertz, which is a great pity, so I'm very jealous of you with yours, because I'm interested in long wave. So I built this, which is a converter. So this converts frequencies below 1 megahertz to 10 megahertz. And it's got a little battery in it, and obviously it's not normally got the thing connected as a loop. Yeah, and the only other thing I can offer you is a stand. Well, an STL for a stand, which is on Thingiverse. Yeah, I think that pretty much covers it. Martin, your Pluto trials and tribulations, that was a well-known issue. Less likely with the Ethernet, even though you're running it on the Ethernet. Oh, and the power, the diode, I suspect what the problem is you've not got a very good match. And it depends on the wavelength. So however many adapters you've got is changing the wavelength. So it might be a good idea to put something like a 6 dB pad in there to try and damp down any of those resonances, assuming you've got enough coming out of the coupler to still measure it. That might help a bit, I don't know. But the one I've got, the one that tells me what my power is, which looking at the internet is 11 watts, drop down a bit, is just measuring the voltage. The PA itself has a diode detector built into it, and it gives out a voltage. And all I did was I used my HP 435 power meter and calibrated that against the output power via an attenuator, so that I now know roughly what voltage is related to the power, and it gives me a number. And as long as I don't put too much faith in it, then it's at least it gives me an indication. I wouldn't say it's repeatable and accurate, because it isn't, but it's good enough. Because what you really want to know is if it's working properly, more or less. You don't want to know if you're running 10 watts or 12 watts normally, unless you're building an amplifier and checking its efficiency. Okay, enough of that. I've got to pass it round to Ed, haven't I? PY2RN G0 MJW. Over to you, Ed.
It's unlike it not to come up. All right, I'm just wondering if Brian G6HFS, if he would like to come up, because I did see him and then suddenly he disappeared. Oh, you can't see my face. Wait a minute. Apologies for that, guys. Let me just switch this one off. Okay. I just want to see on WhatsApp if Brian wants to come up. He did say he was watching, but he was on. He says he's just watching today. All right, it's going to be a short net today. I just want to say good day to Graham at G3 Yankee Radio, to Nigel at 2 Echo 0 Echo Hotel Hotel, to Chris at 2 Echo 0 ILY. And Chris, I did answer you, but I'll show you in a minute. And then there's quite a number of guys on YouTube as well that we want to say hi to. And I just want to catch up with the notes quickly, and then we can just see who's all on.
It's easy.
Sorry, let me just see. There's the normal. There's Dave Shaw. He's at work. And let me just turn down this volume. Oh, for God's sake. Let me just see who else is on. There's Dave Shaw, Stuart Clark, Ohan, and then Peter, GW7BZY. He said he's at the salt mine, and then Ohan again. But all good. On the power meter, Leon can also give some more information. This is what we did. Let me just take the camera away. That's a power meter that it's a digital power meter, so it is terminated inside, and of course it can go up to about 0 dBm from minus 60 dBm, and then you just use a normal cable to attach it into your USB port. Extremely accurate, but a bit of a snag that we found anyway. And that is, I tried to put it on a DATV signal, and it was running up all over the place. And I just couldn't get a reading on the thing. And to discover that one has to put a very stable sine wave into it, like you would get from a generator or whatever. It is so sensitive, it measures your amplitudes and your digital streams. So to cut a long story short, we did a truth table on so many amps, put a sine wave in, so many, on the power supply, so many amps gave us then so much power. But what, of course, we did is we ran through a power divider, or a, what do you call this thing? It's not quite a power divider, but damn it. Anyway, and it's got a 30 dB attenuation to it. And then that worked quite well, because you could read, of course, what you were doing there. So once we now could put the sine wave in, it worked well, and we could then determine what the power was, and then just looked at the power going into your amp, and we could make like a truth table from that. And that worked out in the end quite accurately. Now, Leon, he had a lot more time than what I have. So he went through a lot of effort, and he made up a very nice chart with different values, and then he calibrated that against the Marconi, and that of course worked like a bomb. I just want to show you the other pictures I've got of the Marconi, if I can. Now let's see. I wonder. No, don't tell me it's only the one picture. Okay, I'll show you on the next over quickly. I thought I had them all in. Let me just see, maybe I have. Okay, let's see if it'll give us a bit of a slideshow. If not, I'll just pull them up one by one. Doesn't look like it is. Okay, Murphy's playing around with me today. Leon, you can talk more about that, and I'll bring up the photographs. ZS1 Mike, ZS6 Yankee India.
Okay, thanks Gary. ZS6YI in the group. ZS1 Mike returning. Okay, yes, I got Mike's over, but I missed a little bit of Matt and all of Martin, because I had a visitor quickly who dropped off something that I must have a look at for him. Okay, the power meter under discussion is this one. Let me just get it. Oh, yeah. It is a Marconi Saunders microwave department of Marconi that manufactured these. You get several power heads for it. The ones that Gary and I are using now is the highest power one. It goes to 3 watts. And then you have, I'm on the wrong side, everything is mirror. We are using that setting. That is 0 to 100 milliwatts. And you go up there, it's 3 watts. That is what the power head can do. It's made in England, so Martin, we need your help. Okay, this one is also working fine. And this is the power head that plugs into it. It's a proper thermal thing. It's a perfect 50 ohm at all frequencies. It's got a fine calibration chart there, and there's your efficiency knob. Now, from 10 megs to about 2 gigs, it's flat. And then the efficiency drops, so you just look on the chart. At 2.4 gigs, you go to about 98%. So you set this dial to 98. That's all you have to do. For the rest, it is perfectly calibrated, and it's got extremely good resolution. Even though it's got an analog needle, it is a very well calibrated thing. With a normal N-type connector at the end. I have several of these, but they're all buggered. Gary's got a good one now, and I've got a good one, but I have more of these 3-watt ones. They have what they call a TFT element inside, which in those days, in 1973, was an easily replaceable item which you could get from Marconi. But let's see if Martin can find us this place. This is the manual for the Marconi, for the power head. Marconi Instruments, Saunders Division, PO Box number 10, Gunnels Wood Road, Stevenage, Herts, England. Does that place still exist, Martin? They even have a phone number and a telex, believe it or not. Telegrams, my word, telegrams. Because in this book they show you exactly how to replace that element. There's a nice exploded view there. There's a nice view of how the thing comes apart, and I've had one of them apart, and all the sequence and everything. Somewhere I must have the main manual for the instrument itself, but this is just the manual for the power head. Anyway, yeah, I also have one of these mic 40 dBs. I think it's DC to 4 gigs if I remember correctly. 250 watts. So this works well. And it's continuous. And I have smaller ones as well. But yeah, what Gary was referring to, we're using a directional coupler, a 30 dB directional coupler, and you can screw this Marconi power head directly onto it, put it to 100 milliwatts, then you're exactly 0 to 100 watt scale. Or if you press the next button, which is 30 milliwatts, I think, then you have 0 to 300 watt scale. If you press the 3 watt one, obviously you have a 0 to 3 kilowatt scale, but I don't think the directional coupler is going to stand up to 3 kilowatts. But for 100 watts or so, it's definitely good. Now, the beauty of this thing is it measures true thermal energy. It's got this resistive element inside, which is microwave RF wise perfect, from 10 megs to 12 gigs. And it measures the temperature with a thermistor. And it's amazing how quickly the response is. So no matter what type of modulation, AM, FM, broadband, narrowband, single carrier, it doesn't matter. You always get the same reading. It's the true RMS power that you measure with it. Whereas these little electronic things like Gary showed there, they're very nice, very accurate. I've checked them against my spectrum analyzers, other power meters, and all sorts of things, and the output of my generators. They're spot on, provided it's a pure carrier with no modulation on it. Because they measure voltage, and if the peaks of your carrier varies, obviously like we have when there's modulation on it, then you get all sorts of varying things. Whereas a thermal one is perfect. It gives you the true power. We used on the, by the way, yes, our television transmitters were also Marconi. They were 12 kilowatt Marconi transmitters, and during the annual maintenance you have to measure the output power, and there we had also a calorific method. We had a water-cooled dummy load. Switch the transmitter through to the dummy load. You measure the incoming water temperature and the outgoing water temperature, and you have a flow meter. You set it for a specific flow rate, and there's a little formula, and it gives you the exact RMS power that you're putting out. So it's 12 kilowatts peak sync, because it was AM vestigial sideband, the normal analog television. And that gives you, it was around about 8 point something kilowatts RMS that you get from a 12 kilowatt peak sync television transmitter. But that's also, but I mean, it's a messy business. It's not quick. You have to make sure your water flow is stable, and then measure, give it some settling time, measure the input temperature and the exit temperature, and then plug it into the formula, and there you've got the true wattage. But these Marconis are perfect for the power levels that we are running at if you use a directional coupler. Or the 40 dB attenuator will also work. So yes. Okay, that's the story. Matt, back to you. You wanted to know something. Was it about the power meter? I hope I've answered that. Can't remember. But you have my full attention now. M0 DQW for the group ZS1 Mike.
No audio. There we go. You should have audio now. Yeah, thanks, Leon. Now, what I was asking was whether you were going to upload the rocket footage to like YouTube so that we could have a look at the footage in the fullest resolution that you've got, that the footage was recorded in. So if you're going to do that, that would be awesome. That'd be pretty good. Yeah, interesting about that power meter. When you lifted it up, I thought to myself, "Wow, that's huge." It's I didn't realise that it was such a big device. But I guess, you know, Marconi was a name in that industry where everything works properly, and it's British, isn't it? This is good. In fact, fun fact, I actually had a family member who worked at Marconi, and I think it was over near Watford at the time, but unfortunately he's passed away now, but I only found out that he worked for Marconi after he passed away, which was, well, it kind of upset me actually, to be honest, because this could have been a lot of interesting conversations. But anyway, there we go. Yes, Mike, I didn't realise that they'd done another one of these. In fact, I hadn't even heard of this until about 2 or 3 weeks ago. It was just I was just made aware of it, and then they sent me one to try out. So yeah, I'm looking forward to really getting into this and having a look. It'd be quite interesting. Interesting point that you made about, or a couple of you made about when measuring power, the modulation. Obviously with DATV, it's wider than than just a single sine wave or whatever. So obviously that's going to have an impact on readings, on everything that on all the different kind of sensors or things that you use. So I'm kind of wondering if some of the methods that I've used to measure power, RF power, has been affected by that. I guess for me, my aim will be to have it so that I can have an RF value shown in this screen, which is my dashboard. And like I said before, I did use the that cheap Chinese RF 8000 device, but like I said, it didn't appear to give any meaningful readings when it was connected to the output of the main DATV amplifier. So anyway, so that's my goal. So I think I've got some parts on order from Farnell, which to make up that little diode circuit. So it'd be interesting to see how well that works. Apparently it's quite critical on the board. I don't know how well you can see that, but they've drawn it to millimeters. So each square on there is a millimeter, and apparently you have to make it exactly the same. And I have actually ordered some copper plated double-sided with I think he uses FR4 PCB material with a thickness of 0.8 millimeters, and that's what this is. So I've got quite a big sheet of it, because I think that is actually 20 mil by 15 mil. So if I make a mistake, I've got quite a bit that I can use to keep trying. And I think I've ordered 10 of each components as well from Farnell. So hopefully they'll come tomorrow, and then I'll experiment with that. As you probably know, my transmitter and receivers is all outside. If only you knew how to use KiCad, Matt. What do you mean? I made a board. Did you not see my video? Did I not? Hold on a minute. I haven't got any here. Did I not? I can't remember the last time I was on here. So, I did make a power meter. Oh, hold on. Let me put the big camera back on. So I did. All right, I see. Yeah, I did make a power meter. This is obviously someone else's design inside. But I was playing around with KiCad last night, actually, and you're right. I don't really know how to use it because I wanted to make this. You know, let me see. I'll see if I can make this. Can I make this larger? I'm going to start pressing buttons, and I'll probably end up. Yeah, there we go. Am I still transmitting? Yes, I am. So in KiCad, obviously all this blue area here is basically the copper of the board, and the white area is basically a gap, which you kind of just cut out. But I was trying to make this board in KiCad last night, and I must admit it was quite late. It was about 1 o'clock in the morning. I was quite tired, so I think it would be pretty cool if I could make this board in KiCad to the exact specifications of what's here. And I suppose you could kind of mass produce it if it works, you know. But yeah, I might try that again. I'm definitely going to try with the copper. I'll try with the copper plated PCB thing that I've got. You could make the board in KiCad and get it made by JLC. Oh, right, yeah. JLC, yeah. Yeah. I've used PCBWay. But anyway, I haven't used JLC yet, so yeah, maybe I could. But yeah, I just need to learn KiCad on how to literally specify board size properly and then basically make it look like that. There's me looking over there at it and then I'm not even showing it on the camera. But anyway, I don't think I made any more comments about that. But anyway, I'll stop waffling and I'll put it over to... Can't remember. Oh, it's Martin. Yeah, over to you then, Martin, from M0DQW.
Well, there you go, from one waffler to another. Yeah, you forgot me already there, Matt. There you go. Yeah, and I don't know why I'm commenting on the dish. Yeah, it's fine. It'll have gone rusty by the time you get it out. Yeah, what was I going to say? Yes, that's a very complicated board you've got to make there. You'll be out with a mini drill and sort of takes me back to the ferric chloride and Dalo pen, etc., or even some spray on stuff and putting it in front of the sun, not having the appropriate mains. Anyway, my test equipment. Let's start with this piece of kit. It's what I've used for so many things. You can set it up to where you like. There, which is my PA, 10 gig PA, and it'll be number 6 on the meter. But I've used this for years. It's got a unit that came from GWM Radio in Worthing in the bottom there. It's a sort of a commercial piece of kit, I suppose, with nicely detected diodes. I forget what you call them. They were quite long, pointed ceramic sort of things that you point in. You can select different sensitivities. I used to have loads of them. But that I use as a reference point, obviously with a dummy load from all the transmitter kits that I used to make, which I could stick it to 10 watts. It's just got loads of writing on the side. As I said, loads of bits of writing. And I said, there's a little sticky on there. It says new PA, 10 amps at 28 volts, gives me 6 on the meter. So at least I can see whether things have failed. And first of my dummy loads is my 12 watt one. Actually got a little tiny one, but that's my 12 watt one. And my milliwatt meter, it's got a proper meter on it. Actually, it does a half a watt and 1 watt, roughly, that I've calibrated up to. I tend to just use other more cruder things to measure the lower power stuff. And my slightly higher power, it's up to 25 watts, is this beastie. GWM radio, but yeah, it does. Good old GWM radio. Used to go down there every Sunday morning. You'd open up on something with Greg and Simon, who when GWM radio, Les Grout used to be there. Really big, stomachy guy. Let's pick it up. Oh. That's what it looks like. It's got an N-type on the end. That works well. That came from GWM radio. So that's another bit of test equipment and a selection of attenuators. This one I think is 10 dB up to 12.4 gigs. 1 watt. And a little 20 dB one. all things are useful. But that's most of my test equipment, most of my repair bits of kit. I tend to just what things were running and what things are running next time as reference points. And my meter says I'm running 3940 watts, which go over to that's the outside world. That's not what I wanted really, but not really. No, that's it. That's the power running. The current, it says 14-15 amps, 27 volts, and temperature of 31 degrees. And Marconi at Chelmsford. Used to have a mate of mine that worked there, Henry Barzinski. He was on the south side of the big HF sort of type aerials. They used the sort of light sort of fiberglassy sort of mesh sort of really light sort of stuff that for making the recipe. I'm trying to read all the chat which keeps going up there. But I used to travel up to Chelmsford, and they had a little sort of all the staff etc., which was like GWM radio, and so you could get all this 19-inch rack stuff up there. So as well, I worked in the TV trade, so I used to load the car up with TVs, drive up to Chelmsford, plug the TVs, and come back with all this kit from Marconi. TA girl, eh? This guy. I do like the fact that now I've got the chat and it scrolls up. Plus that the text is large. So thanks to Tom, if I didn't say thank you to him, and the updates to the latest version of OpenTuner. I think is great. Absolutely, what I'm using now is my go-to piece of kit. Right. I think HFS. Oh, it's Mike next, isn't it? That's right. He's going to have lots of reminiscence of GWM radio, and of course the Brighton rally, which was a massive rally. Talking about rallies. Anyway, enough waffle from me. Good to be on the net, and yes, I know that was a common fault there, Mike, with the Pluto. Yes, I had noted it and I learnt it all, but when you get old, you start forgetting things. Can do better. Anyway, put the test card and back to you then, Mike. From Golf 8 Kilo Oscar Echo.
Right, well, you don't have to be older to keep forgetting things. Mind, I am older now, I forget everything. Okay. Lots of interesting things. Again, let me just go to this. Don't worry, I'm not going to do a 5-hour tutorial. All you need to do for what you want to do, Matt, is use the PCB tool. So just open up an empty project, and when you click on that PCB editor, it'll come up with a PCB editor. Of course, it comes up with it in a different window. So I need to fix that, which I'll just do now by going to display capture, and hopefully you can see that. Sorry, it's a bit small, but hopefully you can get the idea of what's happening here. And you get this sort of the blank PCB. Now we've not got a schematic or anything like that in with this, and I'm just wondering if I can find a way to make it bigger. Does control work in KiCad? No, it doesn't. Okay. What you need to do, and it's going to be a bit difficult to see this, I'm afraid, even in the resolution I've got it set to here, is basically just draw a board. And the first thing you need to do is work out what layer you're going to do it on, and the one to do it is edge cuts. So you go to the edge cuts and then you draw a layer like that. That's your PCB. Now I've not got it turned on at the moment, so you can't see it. So let me just turn all of these things on and make them a bit more visible, and maybe I'll come back with a better, more visible image so you can actually see what we're going to do now, rather than keep going on the net. And effectively, you can just draw your PCB in the KiCad PCB drawing bit for the one you're doing. I mean, you can go through schematic capture and do everything else, but for that board you really don't need to. So with that, I will go back to the test card and pass it on to Gary, I guess. ZS6YI G0MJW.
Okay, G0 MJW ZA6YI returning good. Just want to check that the audio is there. Good, all good. Yeah, that's going to be interesting if you can give a quick tutorial. Hey, there's some lightning and thunder just come up. And yeah, I'm exactly on 16 watts. 16 watts. On the, let me show you now. I've got those photos loaded quickly. I hope it works, you know, Murphy. We take that off. There we go. So that's the little power meter that we were talking about, Matt. And if you're going to go with anything like that, you definitely have to have a good sine wave going in, which it's not so comfortable if you want to look at a DATV signal or a SSB signal, and you just want to know what power you got out. So it's highly accurate though. Leon did the truth table, and he got it to measure exactly with the same sine wave, same frequency, same signal gen going through the amp. He got exactly the same outputs eventually, to the milliwatt virtually. So they're very accurate, but you do need to do to the proper sine wave signal, not no modulation on that signal as such. Right, this is what the power meter looks like, which I'm using right now, and it's 16 watts on the dot. And then I go through a directional coupler. Now, unfortunately, you can't see the label, it's the other way around, but the signal comes in with the yellow, and through the directional coupler to the antenna, and this has got a 30 dB attenuator, and through the pickup. So very accurate, everything runs cool, no heat that I could detect. And immediately after this over, I'm going to quickly feel it. Switch off, of course. I don't fancy an RF burn. And that's the actual power head. I took a close-up so that you can see the make. This one can take 3 watts maximum, 3 watt in. So you have to go through that directional coupler. And by doing that, you don't need massive heat sinks or anything of that nature. And it works very well. So there we go. Right, gents, I think I'm going to call it a day on the link on this net. But we can carry on because there's some interesting things that Mike's going to show us. I want to run off because I've been called to come for an early supper. So I wish everybody on Frequency a happy week. And we look forward to, Easter Sunday we'll be on for whatever. And let's hope we can say at least hi to each other over the Easter weekend. I think it's next weekend, if I'm not mistaken. Right, with that, Leon, sir, to you. ZS1 Mike to take it from ZS6YI. ZS1.
Okay, Gary, ZS6YI in the group. As it is one Mike returning and also saying cheers to everybody. And okay, Matt, yeah, Gary and I, we were discussing it. We are going to do those videos. We're going to redo them at 1 megabit, not 333. Then he's going to stream it into his letterbox or something that he has, where you can forever go and have a look at it afterwards, and it'll be in a better resolution then. So it's going to happen. So okay, that was Matt's question. Martin, okay, nice to see all your merging goodies and things. Yes, well, if it serves the right purpose for you, that's fine. You've made your mark. It must be 6 on that amp, and that's it. That's good. Okay, I wonder what's happened to FKK. He's very, very scarce nowadays. Yeah, Martin, so I wondered, can one still contact these Marconi people? Because I'd like to fix the other power heads as well. If I can just get that, it is a replaceable item in 1973. I doubt if they'll have some stock left there in a dusty shelf somewhere there. They've probably relocated the factory a million times after that, after 73. But anyway, it would be nice because nothing else goes wrong in them. It's just when people at the broadcasting, we have the final output combiner in the TV transmitters. You have the 12 kilowatts vision coming in. You have the 1.2 kilowatt sound coming in into this combiner, which is it's huge tanks, filters and stuff with probes for measuring SWR and forward power and all sorts of things. And you have to calibrate these. And they push the probes in right against the center conductor because it's 5-inch, I think, 5-inch aluminium outers with something like 1.5 or 2-inch copper pipe for the inner conductor, 50 ohm rigid lines. And they don't start from far away and bring it in gently. No, they just ram it in and then it touches and you get 12 kilowatts into a 3-watt probe. And obviously it immediately destroys that element. But as I say, it was a replaceable item. And if we could just make contact with those people and find out, are they still available or do they have some old vintage stock? Because they really work very nice. Very nicely. Okay, right. That is it from me. I don't know what happened to Ed. I'll scratch him off. He never came up. That's a pity. I like his cartoons in the beginning. So that's it from ZS1 Mike in Worcester, South Africa, saying cheers for now. And we'll see you next week. So over to you, Matt. M0DQW for the group. ZS1MM is still listening.
Thanks, Leon. Let's make sure got audio. Yeah, got audio. Excellent. Okay, guys. Well, not much more from me, really. Interesting and lots of interesting topics today. And thanks for showing all the gear as well. It's really interesting, actually, to see a lot of the older equipment that's still being used. It's pretty good. And I guess that sort of stuff, that sort of equipment will probably be found at like rallies and things like that, or obviously eBay, where prices will be overinflated most likely. But yeah, I think I've never really had the need to have proper calibrated sort of test gear in the shack, as it were, because I've always been into like electronics and things like that. And I used to actually work for a company sort of when I left school, where I was I was a test engineer, and it was mainly infrared transmitters and receivers. It was for like conference centres, like like delegates would have these little infrared receivers, and you'd have different channels for different languages, so like translators and stuff. And I used to work for this company that manufactured basically manufactured everything from the microphones to the transmitters to the big infrared transmitter panels. And I worked on the production team building it, and then I eventually then transitioned into the test department, where we would actually have a lot of test equipment and stuff. So using test equipment, and is not new to me. It's just I just don't currently have any. I don't have anything that works up to microwave frequencies. So I think my job, what I'm trying to achieve now, would probably be a lot easier if I had some decent calibrated equipment that I could look at. I do have some things, like I have a tiny SA Ultra, although that has some issues, because when I built my the meter that I showed you earlier, to calibrate that, it has a calibration procedure, and to calibrate it, you first have to put a minus 10 dBm signal in, and then a minus 40. So I wanted to use the tiny SA Ultra, but for some reason or other, it will output a minus 40, but not minus 10. And then I had some other strange issues as well. I was measuring some of the attenuators that I've got. I've got these little small attenuators, ranging from 2 to 6, 10 dB, and it was really bizarre. I was using one of my, what was I using? Using one of my VNAs, or it could have been might even been using this as like a little tracking generator. And if I put them in individually, in line between the input and output, I could actually see it, and I could see the value that it was dropping, and it actually equated to what the value said. But then if I was using two of them in line that I'd already measured the dB drop, it wasn't giving the accurate attenuation. But anyway, long story short, I need to put my hand in my pocket and buy some test gear. I think that'll make things easier. Anyway, right, 7.3s everybody. Hopefully I'll see you guys next week, if the net's on. And thanks, Gary, for hosting as usual, and everybody else that's on the net. And Mike, if I tried to quickly screen record what you was going to show there, but I think I missed it on that board. I mean, I was actually going to spend some time this evening and try and learn how to do it, because I think you're right. I think, rather than messing around cutting this out, I mean, I will do though for my testing. I will do. I've already got the bits. I've already got the board. I'm going to cut it out. And I can remember actually what Martin reminded me of when I was at college, because I studied electronics at college, and we used to use this with board. We used to use these boards and then I can't remember what we'd done. I think we drew like lines on the board, and then we put it in some kind of solution, and it dissolved basically everywhere where the drawing wasn't. And that was pretty interesting. But I guess nowadays you don't really need to do that, because you can just design it on KiCad if you know how to use it, and and then just get them made really well. Oh, one last thing as well. Yeah, okay. So you're right. And you know what? I really don't know why I didn't pick up on that. Why did I put an SO239 on there? I don't know. Maybe it's because that's all I had. I only done it today. I only done it this morning, and I should have realised. Anyway, I've ordered an N type to make everybody happy. But you're right. I shouldn't be using an SO239, especially as I'll want to be using this at 2.4 gigahertz. So. Anyway, 7.3s everybody, and I'll put it over to Martin. I presume we're all doing the last one. So G8 KOE from M0 DQW. 7.3s, have a good week, guys. I'll see you next week.
Yeah, 7.3s there, Matt. Let's mute the sound. Yeah, you used to have a Dalo pen which you could draw on the, or you used to get Electroset, and you'd put. I'm never very good with the Electroset, but some people could put really nice. And then ferric chloride, you could, if you heated it up a little bit, it was warm, and then you could wiggle the board around. It would, but then you'd always find that it would eat away bits that you hadn't quite covered up properly. It worked well. Built a lot of boards. So you could go down GWM and you'd get all the offcuts of the board for peanuts, and always make the ferric chloride last a lot longer than it should. So it was always weak by the time. It used to take ages to do. But anyway, not a major problem. Yeah, it doesn't worry me too much, other than a reference on sort of power side of things, comparing A to B. I've always been a bit that sort of way. But yeah, the diode and the board that I made up was just based on the guy who built your PA, on his little power meter article that he did in CQTV. And I just followed that, used one of the diodes that he suggested. I forget what the number was, but it's the one that he said was linear. Cheap and cheerful, and just plugged it straight in, and then used the calibration sort of settings that you've got on the DATV Easy in the config to get it to read something reasonable, so that I can instantly see if things have gone drastically wrong. Whether it's 35 watts or 40 watts doesn't actually worry me. But if it's gone down to 5 watts, then it does. Same as on what current being drawn, etc. I know the sort of levels that I should be getting if things are reasonably happy. So that works for me. I think that's probably about all. But thanks to everybody. I should be on next week, all being well. Now that I've remembered to put the little earthing link in Pluto B. My other one's a Pluto C, so I think that has other resistor problems, if I remember rightly. But this is straight in on USB that I'm using it, but I may stick it on the network because it might actually work on the network now. But, it's very convenient. It sits on the desk here, and I can keep an eye on it and see what's going on. And yeah, the Grundig radios and things and that takes me back to where I started off in Barker's of Oxford Road, Worthing is where I used to work. And yeah, they'd lots of Grundigs. It's actually the old TK reel-to-reels. I used to be repairing loads of those. And when I started off, you know, you used to get put in a cardboard box with a fan heater at the end. That's what happened to apprentices or people in those days. But you wouldn't get away with it now. But I learnt a lot and found a lot about mic electrolytics across the mains. As people would plug them in with the clicks plugs that used to, the old 2-pin plugs that used to have. So you come and switch your bench on, and suddenly there'd be an almighty load of smoke. And but anyway, it was good fun. Right, now so Mike's going to give us a demonstration on how to do this CAD program arrangement, PCBs. I shan't be doing it, but I just think it's amazing. I have enough trouble with doing the simple things. And I did watch your Matt, your Node Red video this morning. I thought, yes, will I ever go at Node Red? I don't know. I don't know if my brain cell can handle it, but maybe if I get a spare moment or three. Right, 7-3's all. See you all next week. Round to you then, Mike, from Golf 8 Kilo Oscar Echo.
Okay, thank you, Martin. Hopefully there's a picture of me now. Yeah, good. Right, okay, well, very quickly, because I don't want to bore everyone, here's a bigger version of the screen I was trying to show you earlier. Let me now click on it. Designer, which you'd normally start with the schematic and then go to a PCB design, but you don't have to. You can just do a PCB design. They're all independent programs, and what you want to do is create this very, very simple board. The first thing to do though is define the size of that PCB. So you select this thing called edge cuts in the layer you're working on, and then you just draw the thing you want. At the moment it's doing things in square. Now I don't know what the dimensions are of the thing that you've got, Matt, but as you can see, you can set it to what you like, and I suspect yours will be a lot smaller. You can zoom in with the scroll wheel, incidentally, so that's what I've just done. I've just zoomed in so you can just see that. And that is pretty big at the moment. But what I can do is I can edit it, and I realise you're not going to see, because I'm on a window capture, you're not going to see the edit window. But if you press E, you'll see. Well, maybe you will see it. I don't know. No. Okay. Maybe I'll go back to the desktop and resize it so that you can see this if you give me a second, because it probably doesn't help to not be able to see that. So let me just go back to the desktop. You're not going to see anything for a second. No, you will. Right, now you see my desktop, the wrong desktop. Oop. And this is the KiCad program, and of course it's incredibly small at the moment. One of the features of OB... Oh, sorry, you're not seeing it, are you? So, sorry for the delay here. Just trying to size the screen so it can be seen. Right. Not supposed to be a tutorial in OBS, but I'm drawing in the wrong I'm editing the wrong thing, that's why it looks so... Right, I'm just going to have to go for full screen rather than try and get OBS reconfigured on the fly. Oh, there we go, it's working now, typical. It's going to work. Right. I'm not exactly sure what's going on there. I don't know what's gone wrong with ABS. Right, well, let's just go with keep it simple version of this. It's probably the best way to do it. And we'll just do that. Hopefully you can still see most of what I'm trying to do. What I was trying to do is make it bigger so you could see it. So you've got this bit on the edge cuts, which is the PCB, and then you want to be able to draw on that the copper layers. So what you do is you select a layer, let's say it's front copper. Actually no, let's do back copper first. So this is the back copper. You draw another rectangle, same size, and then resize it so it fits. Like that. So that's how you would draw something, but actually that's not what we really want. What we want to do is we want to fill a zone in. So what we want to do is use the zone tool, and that's this one here, add a filled zone. We want it on the bottom copper, and we just draw around what we're doing, and that's it. That's now a zone on the bottom copper, and because I've got the zones not as visible as they could be, you might not be seeing that very clearly, but it's believe me, it's there. So we got that zone, and then we go to the top copper, and we basically do exactly the same thing. We add a filled zone, but in this case it's on the front copper, and it's going to look like this. So hopefully you get the idea what I'm trying to do. So that's your zone on the front, and that's the basis of the PCB, and then all you need to do is do another filled zone, which is your track, again on the front copper, like that, like that. That's your track, and then you need to add these things called vias, which are the things for the grounding, which they showed some pictures of them right there in your picture. You just click on there, add that, and that's the job done pretty much. So if you now look at that in the 3D viewer, doesn't look like anything because what I haven't done is fill the zones. So I need to fill the zones, and now you see what we've got. Hopefully that helps. And sorry I'm not seeing the chat if there's anything untoward here. Let's go back to the 3D viewer. So now you can see, it's not very clear I guess, but it's really there. There's the track, the little board and the wires as you might want them. So, with apologies for my inability to get OBS to do the right thing on the fly, hopefully that gives you an idea of how to do it very quickly. Quick and dirty version of it. So there you go. Right, with that, 7.3, round to Gary, I guess. Yeah, ZS6YI, G0MJW if you're still there.
But I'm just looking at my picture on the scope here. No, Juan, if you're listening, it's all good. No, that's very interesting, Mike. Tom, hi, Tom, if you're listening, and hello to Andreas and to Ishmael as well. I forgot to say hi to Albert and Ishmael. Hope you guys are well. And Tom came up with a good idea. You know what you should do, if you don't mind, Mike? Give a 5-minute or so tutorial every week that we come on DATV. And you can actually do a video on it, and so that you can show it much easier, because we weren't following all the time. But it's fascinating. That will be wonderful. Benno, I think, said one can also get good information on YouTube. Well, I totally agree. There's a lot of lovely things on YouTube. I've sorted out a lot of stuff with the Grundig that would have taken days, if not weeks. So it was fantastic having Manuel do his bit there. I think he had a 12-part series on this Grundig satellite. I love Grundig equipment. TK45, we started with that. My dad did, and he actually modified the thing to put sound on sound way back in 1961. And then Max Grundig, he sent the plans and how he did it, the schematics, to Max Grundig, and he actually got a reply, and he was invited to come to them in Germany, which he did. And Max presented my dad with a TS transistor studio, they called it, TS 340 reel to reel, which I still have with all those mods that my dad did. He made he couldn't buy stereo controls those days, so he made his own, drilled a hole through the center, and he had little rings, and he made out of like a perspex thing, clicked it out, worked very well. And so they gave my dad that, and they gave him a RT1 firstly, the amp was an SV240 Grundig amp, which I still have, and an RT100 stereo FM receiver, and also with shortwave. In fact, we used that very receiver to listen to the first landing on the moon in 1969. I still have the equipment. Oh, and a dual. It was a DUAL, dual turntable, but Grundig, it was manufactured by Dual, but with the Grundig name on it. And you know, you could take a record and put a pen. You could actually take your pen, put it on the record or below the record, and the whole record would wobble like this, and you'd still hear it in perfect stereo, wouldn't jump. Then you could take the record player, the Dual, And slowly, as you plane it, you lift it up vertically, and the head would run up vertically. I still have that turntable as well. Beautiful piece of equipment. So that is the association with Grundig, and that's why I bought this one when it came up on Facebook or something. Some guy was selling it local, and it never been opened, but caps had dried out over the years. I think this one was a 1978 model. So that's the story. Okay, guys, I'm definitely going to run. Thanks very much for coming up. Matt, we see you next week. We will be on for those that want to chat. And thanks for coming up today. Right, let's just see who might be there. Matt might take it. Well, carry on with the list, but I'm definitely going to run. So it will be Matt and Martin. I think Leon said he's going, but hold on, I'm actually wrong. Leon to take it if he's still there. Then Matt, Martin, and Mike. And then we're off. But I must go. 7-3, guys. This is ZS6YI closing the net. But please do continue. It's very interesting. 7-3 all. But please do continue.